Alright, this video is for lesson 2A. We're going to look at some function characteristics. And what I want to do first is give a little review of domain and range, and hopefully put it in a way that will clear up anything that you did not understand from doing this in Algebra 1. So I'm just going to put some random dots here on this coordinate grid. Okay, and if I want to list the domain, remember is all of the x values. So I have a point here at -2, 1, so -2 is part of my domain. This one is at 0, 3, so 0 is part of my domain because I'm just looking at x values. And then this point right here is at 1, 2, 3, 2, so 3 would be part of my domain. So this would be my domain. And typically we write it in those little bracket things, and don't make fun of me that I can't draw them very well. Alright, so that would be my domain. Okay, now what happens to my domain if I decide to connect these points? Okay, now my domain is not just -2, but it's -1.9, -1.8, -1.7, -1.6, -1, all of the points in between these two dots. So now I would say that in my domain, x has to be between -2 and +3. So the way that we would write that is to say that -2 has to be less than or equal to x, which has to be less than or equal to 3. All right, so it's a compound inequality. All right, x has to be between -2 and 3, and it's or equal to because those points are included. Okay, what happens if I take this same graph and just draw lines like this? And now those arrows indicate that that graph goes forever in both directions. So now my x values can be anything. I can go all the way over to like -700. It'd be way over here somewhere, and this graph would keep going down. But I could go forever and ever in both directions. So then we would say the domain is all real numbers. And I'll show you two different ways to write that. We can write it with a compound inequality, and we say that x would have to be between -infinity and +infinity. All right, that little sideways 8 looking thing is the symbol for infinity. All right, so -infinity means I could go left forever. +infinity means I could go right forever. We could also write this as say it's x is an element of. All right, that's like a curved E. That's the mathematical symbol for element of. And then there is a symbol for real numbers, and it looks like an R with 2 lines. All right, so x is an element of the real numbers. Either one of these is correct for the domain of this graph. All right, now we're going to take that same graph and we're going to look at the range. So remember, domain is x values, range is y values. So again, if I just have the 3 points, then those actual y values are my range. So my range here would be 1. This one is at 2. And this one is at 3. So 1, 2, and 3, those are the points in my range. If I connect these points, now my range can be anything between 1 and 3. Anything between 1 and 3 here, if I kind of, like, let me show you this, if I kind of shade here, anything between 1 and 3 is part of that graph. So my range now would be 1 is less than or equal to y is less than or equal to 3. All right, so that's my range now. Okay, and then I'm going to do the same thing we did for the domain. I'm going to draw arrows. Okay, now my range, it goes down forever. This end of my graph is going to keep going down. This end of my graph is also going to keep going down. So now my range is not all real numbers. Okay, my range is anything that is less than 3. So anything from 3 down, eventually somewhere this line is going to touch. So again, two ways to write it. I can say that y has to be between -infinity and 3. Or I could say that y is less than or equal to 3. And either one of those I would take as an acceptable, correct answer for this graph. One thing I want to point out, and I did the same thing when we did domain, whenever you have infinity, it's going to be less than, not less than or equal to, because the graph can't be less than or be equal to -infinity since it's not an actual number. We're just using -infinity to represent like forever. Okay, so anytime you draw an infinity symbol, it's always going to be less than or greater than, depends on what you're writing, but it's never going to be or equal to. Okay, so in your notes here we have some definitions. The domain of a graph is all the possible x values. The range of a graph is all the possible y values. We just talked about that. All right, the zeros of a graph, hopefully you remember this, are the x values where the graph intersects the x-axis. So zeros, x-intercepts, those are the same thing. Your calculator might also call it roots. Okay, all of those three things are the same thing. All right, and then y-intercepts are where the graph intersects the y-axis. Makes sense, good name for it. Okay, an increasing interval on a graph is the set of x values where the graph is increasing or going up. All right, if I'm going from left to right, just like we read a book, if the graph is going up, that is an increasing interval. If the graph is going down, we would call that a decreasing interval. Okay, and then the end behavior, we're looking at the very ends of the graph. So as the x values approach negative infinity, that would be the left side of my graph. I want to say what happens. And then as it approaches positive infinity, which is the right side of my graph, I want to say what happens to that graph. So you have a bunch of practice problems there in your packet. I want you to skip ahead to where you see this one where it asks you for all of the things. We're going to go through all of the things so that you understand the notation and how to find it. So domain, if I look at this graph, I would go to the left first and then to the right. So as I go to the left, is this graph going to keep going forever? Yes, that's what that little arrow tells me. So I know that negative infinity is going to be less than x. And then as I go to the right, it stops at that point. So it stops at 5. So x has to be less than or equal to 5. That would be my domain. Range, we're going to do the same thing. Does this graph go down forever? Yes, that's what that arrow means. So negative infinity is less than y. Does it go up forever? No, it stops right there, and that y value is 2. So y has to be less than or equal to 2. All right, zeros, those are always going to be written as x equals. So where does this graph cross the x-axis? It's right here at 0. So my 0 is x equals 0. Okay, x-intercept is the same as zeros, but we're going to write it as an ordered pair. So that point is 0, 0. That's my x-intercept. My y-intercept is where it crosses the y-axis, which also happens to be 0, 0. Those are not always the same, but they can be. All right, increasing intervals. As I'm going left to right across this graph, okay, where is it going up? Well, it starts going up wherever I decide to start. So that would be negative infinity. All right, is less than x is less than, and it keeps going up all the way to 5. Okay, anytime we do increasing and decreasing intervals, these are always going to be less than. They are never going to be less than or equal to, because a graph cannot be increasing at a specific point. It's over an interval. Okay, decreasing intervals, if I'm going left to right, this graph is going up the whole time. It never goes down, so we would say none. Okay, and then this is asking for our end behavior. So as x approaches infinity, as we go to the right, y approaches. We're going to say that end behavior does not exist because our graph stops at a point. As x approaches negative infinity, as I go to the left, this graph is going to keep going down. So y is going to approach negative infinity, because they're going down as I go to the left. Okay, I'm going to do one more example with you. Go ahead to number 6. Okay, domain, again, left and right. So is this graph going to go left forever? Yes, that's what that arrow means. So negative infinity is less than x is less than, is this graph going to go right forever? Yes, that's what that arrow means. Okay, so negative infinity is less than x is less than infinity, or like we talked about before, you can write that as x is an element of the real numbers. Either of those things would be correct. The range, is this graph going to go down forever? Yes, don't be confused here. It looks like the graph flattens out, but it doesn't flatten out straight across. It's just going to kind of go down very slowly. Okay, is it going to go up forever? Yes, same thing. It's going to go up very slowly. So that is, again, between negative infinity and positive infinity, or y is an element of the real numbers. Either of those would be correct. Zeros, where does the graph cross the x-axis? Right there. We're going to call that 1/2. So x is equal to 0.5. X-intercept, I take my 0 and write it as an ordered pair. So that is 0.5, comma 0. All right, y-intercept, where's the graph cross the y-axis? That is right there, halfway between -1 and -2. So that would be 0, comma -1.5. Increasing intervals as I go left to right, going up, going up, going up, going up, going up the whole time. So that is negative infinity to positive infinity. Decreasing intervals, there are none. It's never going down. Okay, as x approaches infinity, as we go to the right, the graph keeps going up. So y also approaches infinity. As x approaches negative infinity, as I go to the left, the graph keeps going down. So we say y approaches negative infinity. All right, and that's it for 2a.